It's time to start creating your containers using Docker in the terminal. Let's take a quick look at what our structure will be so we have a good idea of what we'll be creating and how they'll work together. There are three main pieces to the setup of our grid: the Docker machine, aka the Docker engine, the hub container, and the node containers with the browsers that are connected to the hub. Our tests are run against the hub, which balances them across the nodes. I'm running these Docker commands and tests through my current laptop, so we can think of it as the Docker engine that the hub is connected to, which ultimately connects the browser nodes. Like I said, the hub and nodes are containers, and if you remember, containers need to be started by using images. We get these images from a place called Docker Hub, which is a repository for holding our images. You can either save your images to the hub, or you can download them from the hub. So let's get to it. Alright, so the first thing we're going to do is let's go to hub.docker.com. You should already be signed in from the previous chapter, so hopefully that's the case. If not, just click sign in and log in. Once you're here, we're going to enter Selenium. We'll search that. We'll get quite a few results, and the one that we're looking for are the official images from Selenium, and you can see those pretty easily because they either start with Selenium or it says by Selenium. That's how you know it's from Selenium HQ. And so here we'll find the hub, we'll give this guy a click, and then you'll actually see there's more information about it on their GitHub, and then even the Docker pull command that we'll use in the terminal. So let's grab this guy, we'll copy this. We'll switch over to a terminal and then just paste it in here, Docker pull Selenium hub. I'll hit enter. Sure enough, it's going to start pulling it down. Downloading everything that we need. We'll wait a sec. And there we go. The best way to see that the image is actually downloaded is by going Docker images, hit enter, and you'll see there's the repository, the tag, the image ID, when it was created, and the size of the actual image itself. So now we'll clear Docker pull Selenium node Chrome. Bring this guy down. Chrome debug. We'll do Firefox as well, the headless version, and finally the non-headless version. Now that we have the 5 images that we want pulled down from the hub, we can now say Docker images one last time, and sure enough we should see all 5. Firefox debug, Chrome debug, Firefox headless, Chrome headless, and the hub. We can start creating containers now that we have the images. You are able to run and start containers one at a time through the Docker run command, but we don't really want to create one container at a time. We'd much rather create the containers and network them together in one command. Finally, it's time to get spicy with some Docker Compose, y'all. Docker Compose is a part of Docker but has its own commands and uses a YAML file to know which images you want to use, how you want to create those containers, and link them together. You define a single YAML file with the services you want, and then use the Docker Compose command to create all of it at once. You guys, I am so excited to finally get into code. You can either use the docker compose.yaml file I've included in this chapter, or you can follow along with my C# project by going to github.com/lsnowman/esportsautomation. Just make sure to check out the demo Scaling with Docker branch. For those of you who want to follow along with the esports automation project, you must have .NET Core 2.1 installed, and it will work for either Mac or Windows or Linux. The next thing would be Visual Studio Community is the IDE that I would recommend. It's free and pretty easy to use, but you can also use a text editor like VS Code or Sublime. And boop skadoosh, we're in the code. So I've included my docker compose.yaml file in the test project of my solution so it can be version controlled and easily accessible. So here you'll see esports.tests and then docker compose.yaml. For those of you who are not using the C# project but just have the file, just put it somewhere either in your current project or somewhere that's easy to follow, maybe like a Selenium grid folder off of your home drive or something like that. But let's break down this file. The first thing we see is version 3. This is just saying that this specific file is going to be using the formatting and syntax of version 3, which, as of this recording, is the latest version of Docker Compose files. The next section is services. If you remember, a couple chapters ago, I talked about how services were containers, right? Each container is a service. And so if you think about it that way, you'll see that the three pieces we have, Selenium Hub, Chrome, and Firefox, these are our containers. I'm calling the first container Selenium Hub, and it's going to be using the Selenium Hub image. It's going to be exposing port 4444, and then we'll have a max session of 16, which means that only 16 browsers can be running at one time on this grid. And then I'll put the recommended 300-second timeouts as well. The next container, the Chrome container, will be using the headless Node Chrome image. It will depend on Selenium Hub, meaning that this container has to wait for Selenium Hub to be up and running before this container can be marked as successfully created. I'm then going to be connecting it to the Selenium Hub and also exposing this port of 4444. Lastly, I'm going to say node max session and instances 2, so that way this container will have 2 Chrome browsers on it. The Firefox container is almost identical, except for it's going to have 4 Firefox browsers per container rather than 2. Otherwise, that makes the entire Compose YAML file. Make sure your docker compose.yaml file is saved, and then open your terminal in the directory where you just saved it. For those of you following along, we can just open our terminal and cd into esports/tests. And here is where we'll be running our Docker Compose commands. I'm going to be using VS Code so I have the integrated terminal, but really any other terminal or command prompt will work. In your terminal, run docker-compose up-d and hit enter. That was quick. Let's run docker ps-a to see what we actually ran just barely. What did we just create? This will list all of your containers. Observe that you have 3 containers running now: the Firefox container, the Chrome container, and the Hub. You've just spun up your grid, and you did it within 2 seconds? That's crazy. Even better is that we can actually visually look at our grid by going to a browser. If we go to localhost :4444/grid/console, you'll actually see that you've created a container with 2 Chrome browsers and a container with 4 Firefox browsers, all within seconds. Spinning up our grid was easy, but what about restarting or tearing it down? You guessed it, it's also easy. In fact, it's so easy that I want to go to an ocean and high-five a whale right now. To restart your grid, simply run docker compose restart. Give it a little bit to do it, but otherwise it will completely delete the previous containers and spin up brand new ones. To tear down the grid, simply run docker compose down, and you will stop and completely remove the containers. If we now do docker ps-a, you'll see there are no containers up anymore. With docker compose up-d again, we are right back up to where we were not too long ago. This, ladies and gentlemen, is the power of Docker and the power of containers. Look at this grid going up and down and side to side. It's awesome.